Hi, we are talking about linear systems of equations. That just means we have some lines and we want to know where they're going to cross. So here are our two lines, and you can see right where they cross. This is the graphing method. This is the first one of the three. It doesn't always work well because if they cross in the middle of one of those squares, you don't really have an exact location. So we have a couple of algebraic methods to use as well. So this is the graphing method. You look at the graph, you see where they cross. Um, but like I said, it doesn't always work. So we also have the elimination method. Sometimes the elimination method um, is easiest, sometimes it's not. If you take linear algebra, elimination method is constantly in use. It is the main method for that. So I'm writing our two lines down and I'm rearranging. Well, they don't need rearranging, but I'm making sure they are in columns. The x's have a column, the y's have a column, the equal sign has a column, the numbers have a column. These all have to be lined up for the elimination method. Sometimes you need to move your equations around to do that. And then what we're trying to do here is eliminate one of the variables. So we're going to multiply that blue equation by a 2. When we do that, we'll have a negative 2y in the red equation and a plus 2y in the blue equation. And those two equations, when you add them together, the y's are going to be gone. You could have done this with the x, multiply one of them by a negative sign. That will work just as well. You have lots of choices with these kinds of problems. So we know x equals 1. We want to know the point. Our answer to these is a point. So we need to figure out what y goes with that point. And we put the x value in either equation to find the y that goes with that, and we get our 0.13. So our last method is called the substitution method. Its big plus is that it always works. Sometimes it can be a little nasty, but it always works. And it's the only one that really works well for nonlinear systems, which we'll be doing next. So this time we want to take either one of our equations and get it in the form y equals a bunch of stuff or x equals a bunch of stuff. And again, lots of choices, doesn't matter which one. So look at your equations and see, this one's easy, I'm going to do this. So that's what I did. We've got our same equations that we used before. The colors are switched though. So this one used to be red. But notice that it's in the form x equals a bunch of stuff. Because x equals that, we can replace x in our other equation by 2y minus 5. That's what we're doing. So this is our other equation with the x replaced or substituted. That's why it's called the substitution method. And now we only have one variable and some numbers. We can solve for y. A lot of people make a mistake here. You get an answer y equals something and you think you're done, but we want the whole point. So make sure you don't stop too early. And that's it. Those are our 3 methods of solving linear systems. Thanks. Bye.